Now today we're going to talk about snakes, and I cannot think of a better way than to start talking about snakes by showing a video, or the only video ever recorded, of a gray banded king snake found in New Mexico. But you know, every time I think of snakes, I think of that really great movie from 2006 called Snakes on a Plane. Oh yeah, Samuel L. Jackson. We got to get these snakes off this plane. Now of course, Samuel used a couple more words that I won't use here. Now snakes are sauropsids, and sauropsids are a sister taxa to the archosaurs, which include the crocodiles, the birds, and the dinosaurs. And specifically, snakes are lepidosaurs, which include the lizards and this thing that's called a tuatara. So it's really in the Rhynchocephala, which had their heyday back in the Mesozoic, and they only superficially resemble lizards. Now, of course, lizards and snakes form the squamates, and there are about 10,000 species of squamates worldwide. And of those, about 3,600 species are snakes, although we continually find new species of snakes all the time. And snakes and lizards are both covered in scales that are keratinized, part of the skin that they will shed. And snakes typically shed their skin all at once. Now, we know that the first snakes showed up around 94 million years ago in what is known as a late Cretaceous. This is when there were dinosaurs on the earth, there were birds, but we don't have a really good fossil record of snakes. Unfortunately, their bones are kind of delicate and they don't fossilize very well. Now we know that snakes are a monophyletic group. This is supported by both morphological data and molecular data as well. Now the trick is, what group of lizards did the snakes evolve from? And a lot of people think that they came from varanids, but that link to varanids is becoming weaker with more data. Now the question is, why did snakes evolve in the Cretaceous? What did they evolve from? And one of the first hypotheses is they evolved from a burrowing lizard. And that burrowing lizard might have been similar to a varanid, which is a monitor. Think Komodo dragon or a Nile monitor. And the loss of external ears in snakes, along with fused eyelids, would be good for a fossorial animal. Now, I have a problem with this because usually when an animal evolves to lose some feature like an eye or a limb, they rarely, that I know of, or if ever, evolve it back. Some snakes, as I'll show you here in a little bit, have incredibly good eyesight. The second hypothesis is that snakes came from something like a mosasaur. Now, we do know that mosasaurs came from lizards, and there's good evidence for this as well. Once again, the loss of external ears and fused eyelids would also be good for animals in an aquatic environment. And we find early snake fossils in marine sediments. So that might be where snakes came from. That would mean snakes recolonized the land. So which hypothesis do you think is correct and why? Now, as I said, snakes are derived from lizard, but they're highly derived. And look at that axial skeleton. Now, we have an axial and an appendicular skeleton. Your axial skeleton basically includes your spinal column, and your appendicular skeleton includes your limbs. Think your arms and your legs. Look at that snake. It's all ribs, right? So that's thoracic vertebrae. On us, the ribs only come off of your thoracic vertebrae. And when you look at the snake, you realize that the lumbars and the cervicals are both highly reduced, and you've just added more and more and more of those thoracic vertebrae. Some snakes also have a reduced pelvic girdle. So if you look at boas, you can actually see this little anal spur attached to them there. And it's not attached to the axial skeleton at all. And in some snakes, like the colubrids, they have no pelvic girdle at all. Now, one thing about a snake jaw is not unhinged. That would be ridiculous. It would just flap around and they wouldn't be able to do anything with it. However, they do have what is called a quadrate bone. And the quadrate bone is not rigidly attached. That gives that jaw a lot of flexibility to open up wide. Also, think about your chin right here. Your jawbone is connected in the middle, but on a snake, they're not connected. And that allows each of these two jawbones to move independently. And that also gives a jaw a lot of flexibility. And this is why a snake can actually swallow objects that are bigger around than it is. And some skulls, like the rattlesnakes or the vipers in general, they are highly modified to inject venom. Let's talk some natural history and diversity of snakes. We always like to know the biggest, the smallest, the fastest, the most dangerous. But let's start with the smallest snakes. It's these things called leptotyphlops. And these are blind snakes. They're mostly fossorial. I found this one in San Salvador, Bahamas. I just happened to look down and find it on a leaf. I was pretty excited. These guys are hard to find. Of course, we're more obsessed with what are the largest snakes. And of course, these are the boas and the pythons. And let's start with the boas. Anacondas are by far, well, I wouldn't say by far, they are the heaviest snake. They might not be the longest snake, but they are the heaviest snake in the world. There are unconfirmed reports of anacondas weighing up to 500 pounds. However, there are confirmed reports much less, around 200 pounds. And the problem is so many of these reports you see on the web of 500-pound snakes or 30-foot long snakes, from what I can tell, are not totally confirmed in the literature. And of course, Ice Cube in 1996 had to face off against the anaconda. And what's interesting about boas is most snakes only have one lung and is functional. But in boas, they have a functional left lung that's about 75% the size of the right lung, and they have live young. They're oviviparous. Ovo meaning egg, vivi meaning life. They keep the eggs inside of them, and then once the eggs will hatch inside the female, and then she'll release live young. The other group of snakes that are very large are, of course, the pythons, and there's 41 species, and these are mostly in the old worlds. Now, the longest snake that we've confirmed is 22.8 feet long. That being said, there are records of these reticulated pythons getting up to 26 feet. Although this is unconfirmed, because really the only way that you can accurately measure these things is either when they're dead or when you've heavily sedated them. And there's some anecdotal evidence, take it for what it is, that these snakes might actually shrink a little bit upon death. And if you think about rigor mortis, it could actually, all the muscles could contract and make them a little bit smaller, actually. Now, both the anaconda and the reticulated python pale in comparison to Titanoboa. This lived in modern day Colombia about 60 to 58 million years ago. This snake got up to 42 feet long. It weighed as much as 2,500 pounds. And can you guess what it ate? Try fish. That's pretty wild, isn't it? The largest snake in the world was a semi-aquatic thing eating fish. Now, of course, people are very interested in venomous snakes. And venomous snakes fall into broadly two families. The elapids, which are your coral snakes, and your vipers, which include your rattlesnakes and your pit vipers and your old world vipers. That's a western diamondback we saw a few years ago on the road. Let's start with the elapids. This, of course, include the cobras. The longest and the most venomous of all the snakes are elapids. So the king cobra gets up to 18 feet long. One of the deadliest snakes in the world, I'm not saying the deadliest, but one of them are these sea snakes. This one is pretty cool. Like the extinct marine reptiles of the mosasaurs, the ichthyosaurs, and the plesiosaurs, they are viviparous, which means they are fully committed to an aquatic lifestyle by giving live young. And they can also absorb oxygen through their skin. That means they can get about 25% of their oxygen need just by absorbing it across the water. This, of course, is a coral snake. This is our North American elapid. This is an example of Batesian mimicry. This occurs when an animal that's not venomous, not poisonous, mimics something that is either venomous or poisonous, something that's dangerous. So these king snakes are basically harmless. They just look like the venomous coral snake. The other family, of course, are the vipers. And this is the black-tailed rattlesnake. It is an example of a pit viper. You can see it rattling his tails at me. And as we zoom in, it's flicking his tongue, it's trying to figure out what I'm doing here. And you can also start to see the pits in front of it. Let's take a closer look. Now you can see those pits. These animals can detect infrared. And they can detect as much as 0.3 degrees difference from their surroundings. They are incredibly sensitive to changes in temperature, and this allows them to track down their prey. Rattlesnakes also give birth to live young. And of course, these snakes have highly modified skulls for injecting venom. But not all venom is created equal. I've got two types of rattlesnakes here. Crotalus viridis is the prairie rattlesnake. Crotalus scutellatus is a Mojave rattlesnake. They're both venomous. They will both hurt you. However, Crotalus scutellatus, the Mojave rattlesnake, has a much lower LD50 than Crotalus viridis. Now, LD50, that's a lethal dose that it takes to require 50% of a population. So the smaller the amount of venom, the more lethal it is. And a Crotalus scutellatus is many times more potent than Crotalus viridis. And the reason why they have different types of venom depend on their different types of prey. Are they going after mammals, which are endothermic? Are they going after reptiles, which are ectothermic? So each rattlesnake and each elapid has different types of venom depending on the prey they go after. And of course, one of the problems with rattlesnake conservation is rattlesnakes are venomous. People don't want to be bit by them. They don't want their children bit by them. They don't want their dogs bit by them. So in the years past, there's been these rattlesnake roundups, and basically people have killed thousands of rattlesnakes throughout the Southwest and the Southeast. And in fact, in parts of Georgia, rattlesnakes have almost been completely extirpated because of these rattlesnake roundups. Now, the snake venom is highly modified. It's a modified saliva. Now, and these different proteins have different effects. Some affect blood coagulation. Some affect the blood pressure. Some are neurotoxic and some are cytotoxic. And then lastly, I want to talk really briefly about the largest family of snakes. These are the colubrids. They represent about half of all snake species, and they have no trace of the pelvic girdle. Now, interestingly, the elapids and the vipers have the reputation for being venomous. However, many species of colubrids are also venomous, but they're rear-fanged. So people are rarely envenomated by these rare-fanged colubrids. One of them is a hognose snake, and these are mainly toad eaters. And what's interesting is toads will blow up and get all big with air, and they will actually grab a hold of it and use their rear fangs to pop the toad and paralyze and kill it and then swallow it whole. And briefly, one of my favorite snakes is the Dipsas temporalis. I saw my first one in Panama, in 2008, and they're snail eaters. And notice their large eyes. These snakes see well at night, and their broad heads allow them to have a large prey. But notice that thin neck. That allows them to extend a long ways out and grab the snails. It's pretty amazing. I had no idea that a snake was a snail eating specialist. That's pretty wild. And then this other one that was similar is Imantodius anchoa. Look at that eye. That snake can see well at night, and it also eats small reptiles and amphibians. And out here in North America, we have something called a king snake, Lampropeltis getula. And it's called a king snake for a reason. And that reason is it eats other snakes. And if you look closely on the right, it's actually eating a rattlesnake. They are more or less immune to rattlesnake venom. And then I started this talk with a gray-banded king snake. I'll end it on the gray-banded king snake as well. And unfortunately, I cannot go over all the different types of snakes in the world. So I just showed you a couple that I'm familiar with that I like, and ones that you might not hear about on popular YouTube channels or documentaries. Okay, until next time, this is Tom Kennedy Science.